Okay, so this is another review of 7.5 to 7.7, focusing just on the geometry. And we're going to do trig ratios, find angles using inverse trig, and also solve triangles. So I gave you a ton of problems to do. What I really want you to do is the 1 to 20. That's what we have to absolutely get done. You can do more, and I'll give you some of the answers so that you can have more practice. But I need to see the work for 1 to 20. Okay, so let's start with that. So we're going to have you do two things. Find the ratio of the sine of z, and then find angle z. Okay, those are your two jobs for each of these numbers 1 to 20. So, for example, it's a really good idea to write down SOHCAHTOA repeatedly so that you know what you're doing. So SOHCAHTOA is written down for us. Let's look at the first one. They want angle z. I need to find sine. That means I need to find opposite over hypotenuse. Find the hypotenuse. It's across from the right angle. This is your hypotenuse. From angle z's perspective, I need the opposite. Across the triangle is the opposite. So I'm going to say the sine of z equals opposite, which is 14, over hypotenuse, which is 50. Okay, that is going to be your ratio. So 14 over 50 is your ratio. So I'm going to draw those lines across. Every single time I have a right triangle, I'm going to use the line to get me my hypotenuse. So in my calculator it says to get z now. So this is the first thing I want. To get angle z equals sine to the negative 1 of 14 over 50. So in my calculator, I say second sine 14 divided by 50, and I'm getting an angle. I'm going to round it to the nearest tenth, I guess, of 16.3 degrees. Okay, so 16.3 degrees is my answer there. Okay, let's keep going. The next one asks also for sine, and they want the sine of z. So the first thing I'm going to do is figure out where the hypotenuse is, and it's right here. Okay, from angle z's perspective, if I need sine, that's going to be opposite over hypotenuse. Straight across the triangle is the opposite. So the sine of z equals 7 over 25. Opposite over hypotenuse. That's your ratio. The angle is going to be sine to the negative 1 of 7 over 25. And my angle ends up being, again, 16.3 degrees. Okay, keep going. The cosine of z. So first thing I'm going to do is draw an angle, a straight arrow across, and label that my hypotenuse. Then I need angle z's perspective. I need cosine this time. So I'm going to write SOHCAHTOA here. And if I want cosine, I have to say from angle z's perspective, what's the adjacent? Well, the hypotenuse is the 20. The other side that touches is going to be the adjacent, and that is the 12. Okay, so now I'm ready to use what I've labeled. So the cosine of z equals adjacent, which is 12, over hypotenuse, which is 20. Okay, so that's cosine. So from z's perspective, next door is the adjacent, so that's 12 over the 20. So then to get my angle, I'm going to say z equals the cosine to the negative 1 of 12 over 20. So therefore z, second cosine of 12 divided by 20 is going to equal 53.1 degrees. So that's 53.1 degrees. So look at that. Make sure you're understanding how I'm getting what I'm getting. So you need to get your ratio first, and then once you have your ratio, then you get your angle. Okay, next one. Tan of C. So first off, let's figure out what the hypotenuse is. There it is. I'm at angle C. Tan is going to be opposite over adjacent. So where is the opposite from angle C? It's right here. Where is the adjacent? It's right there. And the tan of C equals opposite over adjacent. That is your ratio. Your angle is going to be tan to the -1 of 21 over 20. And angle C ends up being 46.4 degrees. Let's keep going. Okay, number 5, cosine of Z. First thing, get your hypotenuse so you know where it is. Cosine of Z. From Z's perspective, cosine is adjacent, right? So I'm going to write down SOHCAHTOA. So I need adjacent over hypotenuse. From Z's perspective, the 28 is the adjacent. Okay, so I need the cosine of Z to equal adjacent, which is 28, over hypotenuse, which is 35. So therefore, Z is going to be cosine -1 of 28 over 35. Angle Z, therefore, for number 5, is 36.9 degrees. Okay, so then tan of X. I need tan, so SOHCAHTOA is going to get written down again. Here's tan, opposite over adjacent. Here's my angle. Here is my hypotenuse. From tan X's position, or from X's position, I need opposite, so straight across the triangle. That is your 21 over adjacent, which is the side that's touching the angle. And it's not the hypotenuse. Okay, so for number 6, I'm going to say the tan of X equals opposite over adjacent. Therefore, angle X is going to be tan -1 of 21 over 28. And that angle ends up being, ran into the nearest 10th, 36.9 degrees. Okay, we're going to do a couple more together. Okay, so for number 7, first thing I'm going to do is figure out where the hypotenuse is. It is right here. I'm going to put an H there. Then I need cosine. I'm going to write SOHCAHTOA. Make sure you are spelling this correctly. This is the one thing you really have to memorize. So I need cosine of A. So from A's perspective, I need adjacent, and that's the 21, over the hypotenuse is the 29. So the cosine of angle A equals adjacent over hypotenuse. Okay, so then angle A itself is going to be cosine to the -1 of 21 over 29. So if I put that in my calculator, I'm going to find that angle A equals 43.6 degrees. Okay, let's do number 8. So number 8, I see that I need sine. So I'm going to write SOHCAHTOA again. Sine is opposite over hypotenuse. So from C's perspective, I first want to figure out where the hypotenuse is. That's always the same spot. But from C's perspective, I need opposite over hypotenuse. And the opposite is straight across the triangle, and it's 21. So the sine of C equals 21 over 29. That's your ratio. So angle C itself is sine to the -1 of 21 over 29. Putting that in my calculator and rounding to the nearest tenth, I get 46.4 degrees. Okay, we're going to do two more together. Now you can stop the video at any point and try to go ahead and then play it and see if you're getting the same answers I am. Okay, so first off, get your hypotenuse. It's the 25. Put your little h right there. Write SOHCAHTOA. Okay, writing SOHCAHTOA, what's going to happen is this. I'm going to say from angle A's perspective, I need sine, so that's opposite. Opposite is straight across the triangle. It's the 15. So the sine of A equals 15 over 25. Therefore, A itself is sine -1 of 15 over 25. And A, therefore, is 36.9 degrees. Okay, one last one. The tan of A. So if A is here, that would be my perspective in just a second. But before I even start, I'm going to put a little h here for hypotenuse. And I know SOHCAHTOA. I'm going to write that again so I can look at that right in front of me. I need tan, so that's tan. I need opposite over adjacent. So from A's perspective, straight across is opposite. And then the side that touches but's not called the hypotenuse is the adjacent. So from A's perspective, the tan of A equals opposite, which is 15, over adjacent, which is 20. So to get A itself, remember I always use inverse trig to get my angles, and that is going to be 36.9 degrees again. Okay, so I'm going to tell you to complete these. Complete 11 through 20. Okay, so you're going to do this on your own. And then these are extra if needed. And that's 21 to 40. Okay, so then, continuing on. When I get down here to 41, this we have to do some of these as well, because this is a different problem type. I'm going to find all the missing sides and angles. Okay, so first thing, if they give you an angle, the other angle, and we'll change our color for this, the other angle that's over here, you can get that by saying 90 minus the angle they gave you. So when I say 90 minus 21, I get 69 degrees. So this is 69 degrees, and that's one of the angles I needed to solve for. Okay, so 69 degrees on one of those angles. Okay, what else do I need? It looks to me like I don't have a side here, and I also have an X here. So I'm going to find everything, okay? So since I have an X labeled there, why don't I label this as a Y? Okay, so then let's figure out what we're going to do. I know that this side right here is also the hypotenuse. And I'm going to use SOHCAHTOA to get the missing sides. So there's not any right way to do this. I'm going to use the angle they gave me, and I'm going to say, okay, from angle 21's perspective, the opposite is 13, and the hypotenuse is H, and the adjacent is Y. So I'm going to always use angle 21. So I'm going to say, I'm going to first figure out the missing hypotenuse. So I'm going to say the sine of 21 equals opposite over what? over the x, because that's what the label they gave for the hypotenuse was. So this is a two-step problem. Put this over 1 and say x times the sine of 21 equals 13. Therefore, to get x by itself, divide both sides by the sine of 21. So in my calculator goes 13 divided by the sine of 21. And I'm going to round everything to the nearest tenth. X is going to equal 36.3. Okay, so that's another value that I found. I got this angle, and I've got that side. Now let's go get the other side. So I'm going to keep using that 21 degrees, but now I want the adjacent side, so I want to use cosine. So I'm going to say the cosine of 21 equals, cosine is adjacent, which is the unknown y, over the hypotenuse, which we just found out is 36.3. So this is a one-step problem. So if I say 36.3 times the cosine of 21, I get y. So 36.3 times the cosine of 21. So my y is approximately 33.9 degrees. Excuse me, 33.9 not degrees, because that was not an angle. Okay, so that's my other side length. Now I have everything I need. I have the x and I have the y. Now you may find if you use this 36.3 side, you have a little rounding issue with y. That's okay. Just show your work, and if you have a little rounding thing because of the approximation, that's okay. Okay, let's go ahead and we'll do number 42. So 42, things I need to know. The right angle is right across from this x, which is my hypotenuse. I am missing an angle here. To get that angle, I'm going to say 90 minus the 70 they gave us, and that angle is going to be 20 degrees. Okay, so I found one piece already. That's the missing angle. I'm going to use the angle they gave us, the 70, and I want to find the x, and I want to find the y. So I'm going to say from angle 70's perspective, the y is the opposite, and the 17 is the adjacent. So I could say tan of 70 equals opposite over adjacent. That'll be a one-step problem. So 17 times the tan of 70 will equal y. So 17 times the tan of 70, and that equals, y will equal 46.7. That's another piece solved for. Then, why don't I use the 17 and try to get the x? So I'm going to say, from the 70's point of view, the 17's adjacent, and the x is the hypotenuse. So adjacent over hypotenuse is cosine. To find the next angle, I'm going to say cosine of 70 equals adjacent, which is 17, over hypotenuse, which is the x, which is the missing side. This is a two-step problem. X times the cosine of 70 equals 17. Divide both sides by cosine of 70, because your goal is to isolate the x, and 17 divided by the cosine of 70 is going to equal 49.7. So x equals 49.7, and we have all the missing sides. Okay, that brings us down to 43. And for 43, I'm going to first figure out this is the hypotenuse. From this angle's point of view, I know that this, I can make this y. That's going to be the opposite, and this is going to be the adjacent. Those are the sides I don't have. And what about this missing angle right here? That's 90 minus 28 degrees, and 90 minus 28 is going to give me 62 degrees. So that angle right there is 62 degrees. And let me write that a little bit better so you can actually see it. Okay, so this is 62 degrees. That was an angle that was missing. So that's good. Okay, so the only thing I have is the hypotenuse. So I'm going to use angle 28. And I'm going to say from angle 28's perspective, I want to find the cosine. Say the cosine of 28 will equal the adjacent over the hypotenuse, which I have a value for. This is a one-step problem. Do your cross products. 20 times the cosine of 28 equals x. Put that in your calculator. 20 times the cosine of 28. And I get my x value to be 17.7 when I round to the nearest tenth. Okay, so that's one side solved. Then I need to have another side, and that side is the opposite. So why not use the sine of 28? And that's going to equal opposite over the 20 they gave me for the hypotenuse. Do your cross products. One-step problem. 20 times the sine of 28 equals y. 20 times the sine of 28 equals y. So what's y going to be? 9.4 when I round to the nearest tenth. Okay, nearest tenth is one decimal place. Okay, so that was 43. Let's do 44. Different color. Okay, so what I notice is this x is the hypotenuse. From 35's point of view, this is the adjacent, and I'll make this a y, and that is the opposite. Now go ahead and find the missing angle. I find that by saying 90 minus the given angle of 35, and 90 minus 35 is going to give me 55. So this is 55 degrees. So that is my missing angle. I have that already. Then I'm going to use the angle they gave me. I have the adjacent, and I need to solve for the hypotenuse and for the opposite. So let me just write SOHCAHTOA over here. So I have it in front of me again. And I need to solve for the opposite, and I have the adjacent. So opposite and adjacent is tan. So what if I say the tan of 35 equals the opposite, which is y, over the adjacent, which is 19. So that's a one-step problem, because once I say 19 times the tan of 35, I get 19 times the tan of 35. I'm getting 13.3, and that equals y. Okay, so that's my first side right there. Okay, I need to find what the x is, and that's the hypotenuse. So since I have the adjacent and I need the hypotenuse, adjacent and hypotenuse is cosine. So I'm going to say the cosine of 35 equals adjacent, which is the 19 over the unknown hypotenuse. This is a two-step problem, because when I multiply my cross products, I don't get my answer yet. I have to go one more step and divide by cosine of 35. So 19 divided by the cosine of 35 is going to give me an x value equal to 23.2. And now I have those two values. Okay, so I'm going to do a couple more, and then I'm going to let you work on the rest, okay? So let's say that I will do, this is 44. Why don't I do 45, 46? Okay, so I'm going to do up to 46. So that's what I'm going to do. I'm going to do to here, and then I'm going to say complete 47 to, what do I want to say? How about 47 to 52? And then, so that's up to here. Okay, then I'm going to say extra as needed. Okay, so that's how we're going to handle that. So let me continue going. So I'm going to do two more for us. Okay, remember, always identify your hypotenuse. I need a value for that. I'm going to make that my y. From this angle's perspective, the x is the opposite and the 10 is the adjacent. This missing angle can be obtained by saying 90 minus 31. So 90 minus 31 is 59. 59 degrees is one of the missing items I needed to solve for. Now, I want to use the 31 degrees. I have the adjacent. I'm going to write SOHCAHTOA right here. I can use adjacents for cosine and tan, because that's a value that I have already. So what if I say the tan of 31, that's going to be opposite over the adjacent that I have. Do your cross products, and it's a one-step problem. And if I say 10 times the tan of 31, I'm going to get x equal to 6.0, and that's one of the values I needed. Okay, the next one I'm going to do, I'm going to say, okay, I need the hypotenuse, and I have the adjacent. Adjacent and hypotenuse, that's cosine. So I'm going to say the cosine of 31 degrees equals adjacent, which is 10, over the hypotenuse, which I called y. Okay, two-step problem. Y times the cosine of 31 equals 10. So let me just move this for a sec, and I'll put it back in just a minute. Divide both sides by cosine 31. That's done. And in my calculator goes 10 divided by the cosine of 31. And I'm going to get y equals 11.7. And that's my second value. Okay, so let me just put this back in now. I'll just make it a little bit lower. And I'm going to say complete 47 to 52. Okay, we're going to do one more together, and that is 46. So first thing, I'm going to establish where is the hypotenuse. So I'm going to change color. So let me just get out of there. Let me go to this. Okay, where is the hypotenuse? Right here where x is. That means that the side opposite the 67 is the opposite, and the side that touches it, that's not called the hypotenuse, is the adjacent. Okay, get your missing angle. If the one angle was 67, 90 minus 67, what does that equal? Okay, you should be getting 23. So that equals 23 degrees. And that was something that was missing. So I have that, 23 degrees. Then I have, from this angle's perspective, I have the value for the adjacent. So I need the opposite and I need the hypotenuse. So I can say the tan of 67 equals some unknown opposite, which I'll call a y, over adjacent, which is 20. One-step problem. 20 times the tan of 67 equals y. 20 times the tan of 67. And I am getting y equals, oops, let me make that better. This is 47.1. That's a value that I was missing. So I'm going to highlight that in yellow for us. Okay, so the other value I'm missing is the hypotenuse. I have the adjacent. Adjacent over hypotenuse is cosine. So the cosine of 67 degrees equals adjacent, which is the 20 over the x, which is the hypotenuse. This is a two-step problem. X times the cosine of 67 equals 20. Divide both sides by the cosine of 67. Put that in your calculator, 20 divided by the cosine of 67, and that should give you 51.2. So x equals 51.2. Okay, so see if you can get 47 to 52. I need to see all the work, just like I showed the work here. I also should see your work on these problems that I did for you, because you want to do them on your own as well. Okay, so that should give you lots of things to work on. You've got a lot of review material that you have answers for, so practice all of it, and then we'll have our test, the first class back after the weekend.